Math 112, Lesson 1-4, complex numbers. So complex numbers start with the imaginary number I, which has the value of the square root of -1. Now, up until this point, you've been told you could not take the square root of negative numbers. It's because that was not considered a real number. This is an imaginary number. I is an imaginary number. Yes, there is such a thing. Okay? If I is the square root of -1, then I squared is -1. Okay, so these are things that you're going to need to commit to memory. Right? Now, the reason that's going to be helpful is if I said, let's find the value of I to the 12th. Okay, well, we don't want to have to write this out 12 times multiplied by itself. So what I want to do is I want to say I squared and then decide what power do I raise that to. Well, the power raised to a power, you multiply the exponents. So in order for that to give me a 12, this would need to be a 6. Okay? So what that means is I squared, I just told you, has a value of -1. Well, when you take -1 and you raise it to the 6th power, you get +1. So I to the 12th is +1. Okay, let's try another one of those. If I said, let's do I to the 57th, okay, because sometimes my math lab will get a little crazy on us. All right, well, we're going to do the same thing. I'm going to say I squared raised to some power. And hopefully I'm going to get 57. Well, the problem with that is nothing times a number will give me 57. Nothing times 2 gives me 57. All right, but I do know a number close to that. So if you just ask yourself, you go, okay, well, how many times does 2 go into 57? Well, it goes in there 28 times, right? But not evenly, because that only gives me I to the, let me write it in a different color up here. All right, that is I to the 56, which is not enough, okay? So that means I've got to take what I've got there and say, okay, I got to multiply it by one more I, because now that is the value of I to the 57th. The reason I do that is I squared is -1. All right. -1 raised to the 58th. Now the easiest way to think about that is, since this is an even number, then it makes that negative a positive. So +1 times I gives me I. So I to the 57th is I. Now my answer is always going to be 1, -1I, or -I, and this is how you would decide which one. Just going to take some practice. Okay, so that's imaginary numbers. I told you that we were going to do complex numbers. A complex number is in this form, A plus BI. A is considered our real part of our number, because there is no imaginary there. And B is considered our imaginary part. Now, not the I, just the B. All right, so your real part is A, your imaginary part is B, the number B. All right, so if I write a complex number, this is considered to be standard form when it's in this form, A plus BI. All right, so we would have a number like 2 plus 3I. A is 2, B is 3. Okay? You can add and subtract complex numbers. And when you add and subtract complex numbers, you really add the real parts or subtract the real parts, and then do the same with the imaginary parts. So for example, let's say I have 3 plus 5I. Okay, there's one complex number, and I want to add to it 2 plus 3I. There's another complex number. So in order to add two complex numbers, I'm going to take their parts that are alike. So in this case, that would be the 3 and the 2 are both real parts. The 5 and the 3 are our imaginary parts. So the 3 plus 2 gives me 5. The 5 plus 3 gives me 8, and bring that I with it. I added the real parts and I added the imaginary parts. And my answer is still in standard form. So let's do one where we subtract. And we are going to be careful with all our signs. Again, we are going to identify the parts that are the same. So we've got this 2 and this 1 for our real parts. We've got this 6, and in this case it would be a -1 for that imaginary part. All right, so 2 minus 1, I'm going to actually write these out this time so we can see it. Plus, I've got 6 minus -1. Okay? So that gives me 1 plus, and this one has, this is our imaginary part, so those have an I with them. That 6 plus 1 is actually, that's actually 6 plus 1, so we get plus 7I. Now, another way you could do this same problem, if you're like, oh my gosh, I don't even know what just happened there. Another thing you could do here is you could say, you know what, I'm going to distribute that negative. And so my problem would change to say 2 plus 6I minus 1 plus I. And then we would just combine like terms. So 2 minus 1 gives me 1. The 6 plus 1 gives me 7I. We ended up with the same answer. So either process there is fine. Just be careful with your signs. All right, not only can we add and subtract complex numbers, we can do some multiplying. If I have 7I times 2 minus 9I. All right, so let's distribute the second 7I through the parentheses. I get 14I minus 63, and I times I is I squared. Now, if you left that in my math lab, it is not simplified because we do know the value of I squared is -1. So negative 63 times -1 gives me a positive 63. All right, now some of you are going to get some things wrong in my math lab because this answer that I have provided is not in standard form. Standard form, the real part comes first, the imaginary part comes second. So make sure you pay attention to the directions. This would be standard form. Even though technically they say the same thing, you would be counted off for writing it in the wrong order. So just be careful there. Okay, so that's multiplying. Let's do another multiplying. Let's say if we have two complex numbers that are multiplied by each other. All right, so we're going to do FOIL. Another way to think of that is I'm going to multiply 5 times both of those. Then I'm going to multiply 4i times both of those. So lots of work to show here. So 5 times 6 is 30. 5 times -7i gives me -35i. All right, now we're ready to multiply the 4i. Positive 4i times positive 6 is positive 24i. Positive 4i times -7i is -28i squared. Okay, we have some like terms here in the middle. These two are like terms. -35 plus 24 is -11i. And I squared is -1. So we can't leave that. All right. So So negative 28 times negative 1 is really positive 28. And so now I can combine the 30 and the 28. And I get 58 minus 11i. Make sure that your answer is in standard form. The real part, then the imaginary part. Okay, the next idea, these are called complex conjugates. Now for those of you that took Math 100, we worked with conjugates a little bit, not complex, but we worked with conjugates. Complex conjugates are two complex numbers that have the same parts but have an opposite sign in the middle. These are two complex conjugates, a plus bi and a minus bi. All right? If I multiply complex conjugates, what happens is the I goes away. Now the reason that's helpful is if you are asked to divide 5i by 7 plus I, or let's say you're asked to simplify. Let's say it didn't say divide, it said simplify. Well, the problem here is you may be like, oh, I'm not sure what I can simplify. Remember, I is the square root of negative 1. And remember, we cannot leave any square root in the denominator. That's like math sin. You can't leave a square root in the denominator. So, to correct that problem, I multiply the numerator and denominator by the complex conjugate of the denominator. So 7 minus I. Whatever you do to the denominator, you must do to the numerator. Okay, now we're ready to multiply. So think of it like this. I'm going to distribute the 5i through those parentheses. So I get 35i minus 5i squared. And in the denominator, I must do FOIL. So 49 minus 7i plus 7i minus I squared. Now remember, you can never leave I squareds in your problem because that is the value negative 1. These two middle terms here are like but opposite signs, so that gives me 0. So I've got minus, and then this I squared is negative 1. So I have 35i plus 5 over 49 plus 1. 35i plus 5 over 50. Now, if you try to leave that in my math lab, that is not going to work. Okay, it's going to tell you that is wrong for 2 reasons. The first reason is it's in the wrong order. It's not in standard form. So let's say you recognize that and you turned it around. Okay, still not standard form because it wants for you to write the real part, then the imaginary part. So 5 over 50 plus 35 over 50i. And again, we still are not finished because each of those fractions can be simplified. I know that 5 goes into itself once, into 50 10 times. And I know that 5 goes into 35 7 times and into 50 10 times. So we end up with 1/10 plus 7 over 10i. This is the answer that my math lab is expecting you to give. It is both simplified and it is in standard form. Okay, so another little idea that we need to think about. All right, so let's say we take the square root of something negative. In the past, we were told we couldn't do that. So really what we're doing is this. the square root of negative 1 times b. Well, I now know that the square root of negative 1 is I. And I may or may not be able to do whatever that square root of b is. So let's say I'm asking you to do the square root of negative 18. Okay, well 18 is not a perfect square, but I can do negative 1 times 9 times 2. I know the square root of negative 1 is I. I know the square root of 9 is 3. So I bring out 3i, and this 2 stays inside. Right? So let's make that problem get a little bit bigger. Let's say I have the square root of negative 18 minus the square root of negative 8. Okay, well we just did the square root of negative 18. And we got that it was 3i on the square root of 2. Now I need to do the square root of negative 8. I'll do it off to the side. I know that's negative 1 times 4 times 2. I can take the square root of negative 1, it is I. The square root of 4 is 2, and this other 2 stays inside. So this would be 2i on the square root of 2. Now these are like terms because they have exactly the same radical and they both have an I. So 3i on the square root of 2 minus 2i on the square root of 2 is I on the square root of 2. Oops. Okay, let's do one more. All right, so if we just have a binomial and we are asked to square it, what that means is we are asked to say negative 2 plus the square root of negative 3 times negative 2 plus the square root of negative 3. That's what squared means. So now you have to do a big FOIL problem. So negative 2 times negative 2 is positive 4. Negative 2 on the square root of negative 3. Negative 2 on the square root of negative 3. And plus, when you multiply these two, you end up with the square root of 9. Now the problem with that, all right, because this is a mistake that I think most people are going to make, so that's why I did it this way, all right? We didn't take care of those i's. Okay, there wasn't i's in the problem, but anytime you have the square root of a negative, we need to go ahead and do that. So this line that I just did, we're going to take it out. That's a mistake that I expect people to make, and I want to just make sure we don't do that. All right, so here's what we've got to do first. First, get that I out of there. So that would be I on the square root of 3. I on the square root of 3. Now we're ready to do FOIL. All right, now we're ready to do FOIL. So I get positive 4, negative 2i on the square root of 3, negative 2i on the square root of 3, plus I squared on the square root of 9. So hopefully you can see now why that was important. A moment ago, all we had was the square root of 9. All right, our middle terms are like, so I end up with negative 4i on the square root of 3. I know that I squared is negative 1, and I know the square root of 9 is 3. So negative 3 times positive 1 is a negative 3. And now I've got my two real parts here. This 4 minus this 3 gives me a 1 minus 4i on the square root of 3. That would be the answer that my math lab would be looking for. 1 minus 4i on the square root of 3. All right? So make sure that anytime you have a negative under a radical, for example, like here, let's go ahead and take it out like we did right there. Then we will multiply. Okay, otherwise we would lose that I squared in that particular problem. So now you're ready to do the homework for lesson 1-4. Make sure you try to finish that before we have our team's meeting.